In this video, we'll cover the graphs of sine and cos. The most basic graph for sine, which exists between 0 to 2 pi for one entire period, and the graph of y equals cos of x, also between the domain of 0 to 2 pi for exactly one entire period. We'll cover tan in a later video, but for now, we want to see the pattern of behavior between these two graphs. For sine of x, the way that we like to investigate it is through the unit circle itself. So with the unit circle, we can ask ourselves what the sine measures in the unit circle. That is the y value. So x in this case here is referring to the angle in our unit circle. So if we start off with an angle of 0, our first point that we are investigating on the unit circle is over on the right. Now, what is the y value at that point? The y value at an angle of 0 radians is 0. So that first point there reflects that same point. At an angle of pi on 2 radians, what is the y value? So the second point we're investigating is at the very top there of the unit circle, and the y value there is equal to 1. Now, just looking at the scale here, 1 is located there. And we continue around the unit circle itself. So at an angle of pi, we can see that the y value at that coordinate is back to being 0. Next is at an angle of 3 pi on 2, and we can see that angle, at that angle, the y value is -1. And back around to 2 pi, which is located back at on the right side there, and the y value is 0 again. So how do we connect this? We can see that the y value slowly increases as we go from 0 all the way up until 1. So there seems to be a curve behavior. The way that we connect those curves is through a curve like so. Then as we continue around the unit circle, we can see the y values decrease back to 0. So we're going to attach it again with another curve. Similarly, as we go down to -1, another curve follows, and we go back up to 1, back to 0, sorry. So essentially, we have this 1, 2, 3, 4 curve segments that creates a sine wave or sine graph. Next, we will look at the graph of cos of x between 0 to 2 pi. Now, cos in the unit circle measures the x value. So if we look at the x value at an angle of 0 degrees or 0 radians, which is this point here, the x value there is 1. As we continue around the unit circle, you'll see that an x value at pi on 2 is 0. The x value at pi is -1 now because it's over on the left side. When we go down to 3 pi on 2, our x value is back to 0. And when we return back to 2 pi, our x value, is back to being +1. Likewise again, we connect these points using a curve, like so. 1, 2, 3, and 4. To get the best results for sketching your graph, make sure you lift the pen and draw them as 4 separate segments. That will allow you to smoothen your curve a bit more and have a bit more control. So we can see here for our graph, if we decide to continue on for the sine graph, we will continue on, and this segment will be equivalent to this segment over here again, which means that we are repeating the pattern once again. Likewise, if we continue the pattern over to the left, we can see that the pattern also repeats. So this is one perfect segment of the cycle. So we call this here one period. Similarly over on the cos graph as well, if we continue over on the left here, that repeats that same pattern. And if we continue over on the right, it's repeating that same pattern. So this segment here is one perfect repeated cycle. That is the graph of sine and cosine. Any types of transformations that occur from here, whether it be a dilation with your amplitude changing or your period changing, so it flexes inwards and outwards, or if it translates or reflects, we will use this as our base graph to make all those changes. We'll eventually learn how to look at or investigate the patterns between each point so we can sketch up the graphs a little more quickly.